So in example 5, again, the function is kind of bent. It's not a straight line. So again, we're going to be using Riemann sums to find the areas underneath the curve. And in this case, we're going to be doing 4 rectangles for the first problem and then 8 rectangles for the second problem. So first of all, for the 4 rectangles, so the area is going to be called, first of all, L4, because we're doing a left Riemann sum with 4 rectangles. Left Riemann sum means that we're going to use the left side of each rectangle to figure out how high the rectangle is. So, that's the number. You're going to take the number on the left, put it into the function to get the height of each rectangle. But again, it's going to be area of rectangle 1 plus area of rectangle 2, and so on and so forth, all the way to get to 4. So once you've set it up, you're going to need to remember that each rectangle is each area of a rectangle is calculated by multiplying 2 numbers, the length and the width. So there's going to be 2 numbers for the first one, and same, so on and so forth for each one of them. What you need to be able to do next is get the length and the width of each rectangle. So I'll give you a nice cool recipe to get the width of each rectangle. That way you don't have to worry about it every single time, every single problem. So the width of the rectangles is going to be always like this. Where did the interval start on the x-axis? Where did it end? So it started at 0, it ended at 4. So you're going to do always the second number minus the first number divided by how many rectangles you chose. So again, you basically take the first number and you put it into the formula. You take the final number and you put it into the formula, and you divide it by how many rectangles you want in that problem. So that's going to be 4 minus 0 over 4, and in this case, the answer is going to be 1. So, and you can check it out, from 0 to 1, there's 1 step, from 1 to 2, there's 1 step, from 2 to 3, and so on. So that's the width of all the rectangles. And eventually, you want to factor it out to make the process of plugging into the calculator a little bit faster. You want to factor it out and just put the rest of the numbers together inside the parentheses. Now, what are the other numbers? How do you get the other numbers? Well, what you do for that is you use the function. Remember, the function f of x is, in this case, x squared plus 2x plus 3. So for instance, if I want to know what the function is at 0, all I got to do is put 0 into this formula. So when I plug in 0, I get f of 0, which is 0 squared plus 2 times 0 plus 3, which is at the end 3. So that tells me that the point right there is 0, comma 3. What about when I plug in 1? What do I get when I plug in 1? F of 1 is going to be 1 squared plus 2 times 1 plus 3. So that's 1 plus 2 plus 3, which is at the end 6. So when x is 1, I get 6. And we do the same thing for 3, 2, whatever. So let's do all of them. So it turns out that the numbers that I want are 3, 6, 11, and 18. So those are the numbers that will go in the formula, because each of the rectangle size is width times length. So first one is 3, second one is 6, then 11, then 18. Okay, so 3 plus 6 plus 11 plus 18 after you factor the 1 out, and this all goes into the calculator. So let's see if we can do it. So I'm getting 38. So I'm going to say that the area in this problem is approximately 38, square inches, square feet, square yards, whatever. Okay. I don't know what unit they're using, so I cannot tell you. But again, I know that this is an approximation because I know I'm missing this little gap right there, another gap right here, another gap right here, and for the last one, I'm missing a massive gap. So I know that the 38 is not the right answer for this problem, but for now, we don't have a better way of doing things, except increase the number of rectangles. And that's what we're going to be doing in the next part. So we're going to increase the number of rectangles to be 8. So there's going to be 1, 2, 3, 4, 5, 6, 7, and 8 rectangles. So it's going to be L8. Again, length times width, but they all have the same width. So we're going to write the width first, and then we're going to put parentheses and put the 8 numbers for the height. Okay, so again, how much is the width of this problem? So the last number in this problem is 4. That's this one. The first number is 0. It's not written down. And I'm doing 8 rectangles. So 4 minus 0 is 4, divided by 8 is going to be 1/2. So there's half a step, and so on and so forth. So the width of each rectangle is half. So the numbers are 0, 0.5, 1, 1.5, 2, 2.5, 3, and 3.5. So now we're going to take all the left ones. So the 0, the 0.5, the 1, 1.5, 2, 2.5, 3, 3.5, and put them into the formula. The f of x in this case is x squared plus 2x plus 3. It's the same one from the first part of the problem. It's the same function that we're using. So let's go ahead and punch the numbers into the calculator. So plug in 0 and see what you get, plug in 0.5 what you get, and so on. So my numbers are 3, 4.25, 6, 8.25, and so on. So those go inside the parentheses, and we're gonna go ahead and add them all up together and multiply everything by 1/2, and that will be the solution. So in case you are worried that you're not getting these numbers correctly, or it's taking you forever to get these numbers, let me show you a quick way to get all these numbers that I'm highlighting in orange here with a calculator. Let me show you how to do that very, very quickly. So first things first, turn on your calculator and you're gonna see a screen that looks like this when you click on Y. Once you do that, you're gonna need to type in the equation of the problem. That's x squared for this case, and plus 2x plus the 3. So type it in and now it's ready to go. The next thing we're gonna do is make sure that your table is set up correctly. So click second and window. So again, that's second and then window. Now it gets you into this screen. I want that auto option to not be highlighted. I want my option to be on ask. So if you have it highlighted like this, all you do is go down with your arrows, go there to that line, move it over, and then just click enter there to put it on ask. If it's not already on ask. If it's already on ask, then leave it alone. That means you're ready to go. And next thing you do is click second and then click table. So second graph gets you into the table. Then you punch in the numbers that you want. So 0, 0.5, 1, 1.5, 2, 2.5, 3, and then finally 3.5. And as you can see, it's so quick, right? I get 3, the numbers, and all the ones I'm getting here on the screen, I just transferred them to the paper, and then that's how I'm getting all these orange ones over here. And what I need to do at this point is just add everything up together, multiply by half, and we're basically done. So that one you have to do on the main screen of your calculator. So when I put everything into the calculator, I get 43.625. So that tells me basically that the area is approximately 43.625. And notice that it improved. It was 38, it became 43.625 because we're missing less gaps. As you can see, the original gaps were massive. The new gaps right here are barely noticeable, right? So this is the first gap, that's the second one, third one, fourth one, and so on and so forth.